Okay, thank you very much, everybody, and it's a great pleasure to be here. I'd like to begin by offering my personal congratulations to Bumsoon and his Center for Anthropocene Studies for securing funding for another 6 years. That is absolutely fantastic news for KAIST and also for the wider community. Okay, so I'm going to talk about the Great Acceleration, which is actually sort of a central concept with respect to the Anthropocene. Oops, look at this. Oh, okay, I got it. All right, that's okay. Yeah. Okay, so this presentation is based on the following. Well, it's based on a manuscript of which my co-authors are John McNeill and Jan Zalasevich. And as you'll see, these are actually quite significant figures in the overall story. So what is the Great Acceleration? Well, it was introduced by the Earth System Science community in 2004, and it represents unprecedented increases in both rates and magnitudes of the human enterprise following World War II. A good example of these tremendous increases can be seen here with annual global carbon dioxide emissions. CO2 is really important to the climate system because it's a great magnifier of temperature, which of course we're getting from the sun. So CO2 is a magnifier. It's also, of course, driven by human activities. And of course, the consequences of releasing so much CO2 into the atmosphere is that eventually temperature starts to rise, which we're seeing here. So we're seeing drivers such as steeply rising growth in energy consumption and global economy, which ultimately gives rise to the CO2. And these are, if you like, main drivers. And then we have a response to these drivers, which would include the planetary consequences, which are rising global temperatures, increasing salinity, of course, with the CO2, and ultimately, although there are lags in the system, ultimately sea level rise. We think of the Great Acceleration as coming from Earth system science, which in a sense it does. But actually, the historians can lay claim to being part of this evolution of our understanding of the Great Acceleration. Let me quote from John McNeill, an American historian, who said in the year 2000, in his book, Something New Under the Sun, which Bumsoon has already referred to, in environmental history, the 20th century qualifies as a peculiar century because of the screeching acceleration of so many processes that bring ecological change. Most of the processes are not new. We have cut timber, we have mined ores, we have generated wastes, grown crops, and hunted animals for a long time. In modern times, we have generally done more of these things than ever before, and since 1945, in most cases, far more. He went on to say, for the most part, the ecological peculiarity of the 20th century is a matter of scale and intensity. Now, the basic concepts of the Great Acceleration, which were clearly established by Will Stephan in the year 2004, are actually predated by this analysis by the community of historians. So, it's not straightforward to just say that the Great Acceleration came out of an analysis of Earth system science. You have you have a convergence of views from different sections of the scholarly community. Speaking of Earth system science, it would be remiss of me not to mention James Lovelock, who was employed by NASA to understand habitability of other planets. And of course, as we all know, James Lovelock came up with the Gaia hypothesis. Now, this hypothesis has been discredited on, I would say, reasonable grounds, because it promotes this idea of a self-healing planet, which is actually very dangerous in these present times. But nonetheless, it changed our understanding of, and it focused our understanding on how the planet works as an integrated system. We really owe a great deal of debt to Will Stephan, who passed away last year. He came from the Earth system science community, and he looked at the hard data and he presented it as a series of graphs. These are the great acceleration graphs. They were a milestone, really, in the work of the International Geosphere Biosphere Program. And the final work of that, or the great synthesis of that work, was a book called Global Change and the Earth System, A Planet Under Pressure. And it is in that 2004 publication that the great acceleration graphs were published. So here they are. They weren't at that time called the Great Acceleration graphs because the term Great Acceleration hadn't yet been coined. But that actually is what they were. And they were grouped into human activities or drivers and Earth systems responses. So they're basically indicators or trends of the impacts of human activities. And they recognized the link between overwhelming human drivers, and I emphasize the word overwhelming. This is what we're talking about with the Great Acceleration. The overwhelming drivers of the human endeavor and the responses of the planetary system. And this overwhelming state occurred in the mid-20th century. You can see it very clearly, for example, in population and in CO2, and the various other greenhouse gases. The Earth system science community were expecting a gradual increase in these trends from the Industrial Revolution onwards. They weren't really expecting the sharp change that occurred immediately after World War II, but of course the historians already knew about this. A couple of important concepts that Stephan et al. Raised, and that was one, the concept of threshold crossing. You have two things going on here. You've got forcing, which is linear, and then you have a response which is very much muted by the buffering system that exists within the Earth as a mechanism. But once you cross a certain threshold, then you get an amplified response. And these responses often lead to, they're non-linear, and they lead to irreversible changes. Another important concept is that of the inflection point. It was always understood that these so-called accelerations could not be sustained forever. At some point, they have to start to tail off. And so you get an inflection point. This was already understood and acknowledged at the very beginning of this concept of the Great Acceleration. The term Great Acceleration was coined by John McNeill. And it was coined during a Dahlem workshop in 2005, just 1 year after the Planet Under Pressure book had been published. And it was with reference to the great transformation published by Karl Polanyi in 1945, which was a societal analysis of the 18th and 19th centuries. But both concepts, the Great Acceleration and the Great Transformation, reference the holistic, comprehensive, and interlinked changes to society. And the term Great Acceleration was first published in this proceedings volume of the Dahlem workshop. Dahlem is on a suburb of Berlin. Now, in 2015, Stefan et al. Published an update of the Great Acceleration graphs. The initial ones were published in 2004, and in 2015, they updated the graphs to extend to the year 2010. But in response to criticism that Will Stefan and others had homogenized the impacts of people on the planet, he was encouraged to disaggregate the socioeconomic trends into groups of countries. These groups of countries are the wealthy countries, the developing countries, the BRIC countries, and other countries. And just to give one example of how important this exercise was, if we looked at population, we see that population rises rapidly in the mid-20th century, shortly after the Second World War. And so, for that matter, does gross domestic product and primary energy use. If we look at real GDP, which is really driving, I mean, it is what's driving the Great Acceleration. All this available money and cheap energy is what's driving the whole thing. Not really being driven by population. If you look at population disaggregated, you'll see that the wealthy countries are not contributing very much to population, but they're contributing enormously to gross domestic product. So we have to look very carefully at population when we're talking about the Great Acceleration. It is a complex, rather slippery issue. Let's look at the Great Acceleration and the Anthropocene, because the Great Acceleration does actually importantly help justify the Anthropocene epoch, both in terms of its onset, timing in the mid-20th century, and also in terms of rank. We are talking about scale and magnitude here. And the magnitudes and scale, for that matter, are best shown by these greenhouse gases, which have such an important impact on our planet. The past 70 years and also the future. CO2 is particularly important because of its long lifetime in the environment and long lifetime in the atmosphere. It sticks around for thousands of years, unlike methane, which is even more potent, but only has a lifespan of a week or so in the environment before it gets oxidized. CO2 is around for a long time. 25% of CO2 emitted by humans ends up in the oceans, and we are building up more and more of a reservoir of CO2 that can degas into the atmosphere even once we start sucking it out. But it's the sheer scale, it's the magnitude and the rapidity of these increases which provide us with a justification for arguing that the Anthropocene should be at the rank of epoch level, terminating the Holocene, which was the original idea of Paul Crutzen when he proposed the term Anthropocene in the year 2000. Let's look at the Great Acceleration in some detail here. The Great Acceleration really is a kind of a basket of variables, and every one of these curves is telling you a different story. These red lines demarcate the second half of the 20th century. If we look at plastics, we see that there's been a gradual increasing growth since the 1950s. In the case of ammonia and phosphate rock production, you see an increase and then a decline or a slowdown. Every one of these curves is a little bit different. Of course, China propelled some growth in the 2000s, but what is clear from all of these indicators is that there were significant growth rates and scales during the second half of the 20th century. If we look now at carbon dioxide, we can see that actually it is leveling off. Okay, after that very sharp increase starting off around about 1950, it's leveling off. This is no reason to be complacent. If you've heard of net zero, well, net zero represents this, because these are annual contributions of CO2 to the atmosphere. Net zero would require us to go from here down to here. But things are at least leveling off. In the case of sulfur dioxide, we're actually seeing a decline in the early part of the 21st century. And likewise, global emissions of ozone-depleting substances such as chlorofluorocarbons, these are also declining. That's not to say that ozone levels are improving, but they're just not getting any worse. Really then, the Great Acceleration is a basket of variables. The nature of change is changing. And the drivers and the trends of Great Acceleration are now behaving differently from the way they behaved in the past. So this, of course, begs the question, is the Great Acceleration over? Well, it was initially conceptualized, even before it was named. It was conceptualized as representing a profound acceleration during the second half of the 20th century, essentially restricted to that interval of time. Of course, with the acknowledgement that cumulative effects would continue into the future. On the other hand, Stefan et al. In 2007 considered the Great Acceleration as an ongoing, evolving process, whereas McNeil in 2023 acknowledged that this process is actually losing momentum and must inevitably end. In contrast, I proposed that we return the concept and the term of Great Acceleration to its initial meaning, actually restricting the Great Acceleration to the second half of the 20th century. This, I feel, would restore its intuitive meaning. The transformation, of course, continues, but in a way that is different from the way it was before. I think it would increase the intuitive power and descriptive power of the term Great Acceleration if we restrict it to the second half of the 20th century. And with apologies for not really very much imagination, I would propose we are now in a great continuation. Just very quickly, I don't suppose I have too much time left. I want to, because people are very interested in the Anthropocene vote and what went wrong. And we've just spent an hour talking with journalists about what went wrong. I was asked to say a few words about the vote itself, because a lot of people were expecting the vote to sail through and be approved by now. And in fact, many people were expecting that we would be celebrating a GSSP that would have defined and formalized the Anthropocene at the International Geological Congress in Busan, which I've just been to. And that didn't happen. I predicted it wouldn't happen, but I didn't like to say too much at the time. Well, the GSSP itself is defined in a Canadian, or in the sediments beneath a Canadian lake, Crawford Lake in Ontario, not too far from my university. And the proposed GSSP is in a valved succession that was brought up from the base of that lake in a freeze core. And in case you're wondering, these are soft, soupy sediments. And if you're wondering just how it's possible to bring up core without disturbing those delicate annual sediments, annually laminated sediments, we use a freeze corer. We use basically a metal spike that's hollow, and we put frozen carbon dioxide into that spike, and then we drop the spike into the sediments. The sediments freeze around this freeze corer, and then we bring the corer up, and we then keep the sediments cold so they don't melt, and that's how we're able to preserve these annual laminations. The annual laminations mean that we have annual resolution through that core, and we can analyze individual layers, annual layers, and produce all sorts of wonderful data. It's very painstaking work, but all sorts of extremely high resolution data, including plutonium-239, which is a major signal for the base of the Anthropocene. Let me just quickly go through the process that leads to the ratification of a proposal within the geological timescale. And I've been involved in many of these GSSP proposals, and almost all of them have sailed through and been approved without any problem. In the case of the Anthropocene Working Group, it was set up by the Subcommission on Quaternary Stratigraphy. And the SQS is a member of the International Commission on Stratigraphy. The International Commission on Stratigraphy is a body that represents all of the units of the geological timescale. So the SQS, the Anthropocene Working Group, was set up as it was invited to do, and it produced a proposal which was then submitted, as required, submitted to the SQS. Normally, that proposal would then be passed, approved by SQS. It would then go up to the International Commission on Stratigraphy, which normally would approve the proposal further. And finally, it would be ratified, that decision would be ratified by the Executive Committee of the International Union of Geological Sciences. That's normally how things work. I'm not sure how much of the details I want to go through. I've got a little bit of time, so on October the 31st, the Anthropocene Working Group submits its proposal to the SQS. Discussions begin, but the ICS tries to pressure the SQS to complete discussion within 30 days. Well, that wasn't stipulated in any of the rules. So we pushed back, and we had an extension eventually for 2.5 months, but there was almost no discussion of the science within the SQS. And then there was a so-called palace coup, where the second vice chair, against the will of the chair, called a vote. On March the 5th of this year, the voting results were announced by the secretary of the SQS, and the voting results were yes in favour, 12 against, and 2 abstentions. The 2 people who abstained were myself and the chair of SQS, because we didn't recognise the validity of the vote. The chair then objects, stating statutory violations, which was absolutely justified, on 2 grounds. The leadership of the SQS was usurped by the first vice chair. Sorry, it should be first vice chair held the vote, and also because insufficient time had been allocated for meaningful discussion. On March the 12th, the ICS holds an indicative vote and unanimously approves the illegitimate SQS vote. And then the IUGS Executive Committee voted to approve the ICS vote, which had approved an illegitimate vote. On March the 20th, the IUGS and ICS issue a joint statement approving the vote and accusing the chair and myself by name of attempting to undermine a legitimate process. So you see, this is really very Machiavellian, or Putin-esque, you might also say. The vote, upon reflection, and this is my last slide, the vote within SQS was based on ideology. Many people within the subcommission felt that 72 years is too short, and they weren't willing to consider well-trusted science that shows us the projections for future climate. Processes against formalization were actually driven by just two people in powerful positions: Stan Finney, who was General Secretary of the IUGS, and Phil Gibbard, Secretary General of the ICS. They had already published extensively against formalization, and it was these people who were behind the attempt to discredit actually both myself and the chair of SQS, in order to legitimize an illegitimate process. The reality, however you want to spin it, the reality is that the vote within SQS violated important statutes and was illegitimate. Nothing will change that. The reason the ICS and IUGS did what they did was because they wanted to force a decision through in time for the International Geological Congress in Busan, which took place a week ago. And they were successful, except they left a trail of debris and discredit in their wake. The Anthropocene Working Group will resubmit its proposal at a time of its choosing when conditions are ideologically favorable, by which I mean no ideology. Because when there is no ideology, then you feel impelled to look at the actual evidence. And that didn't happen. There were very few discussions of actual science within the subcommission because, well, if you are ideologically opposed to a proposal that runs into hundreds of pages in length, why would you even bother to read it if you've already decided that you're going to vote against? So the Anthropocene Working Group will resubmit when it feels confident that the SQS is populated by people with an open mind and who are willing to actually look at the evidence. Meanwhile, analysis is underway to examine how large scientific bodies, we can think of big oil, we can think of big tobacco, we can even think of the Catholic Church. How do these bodies react when they are pressured by accusations of impropriety, in this case, controlling the narrative and battening the hatches? In other words, controlling the narrative, which is what they did. As soon as the results came out, they published in the New York Times. And then, of course, they quickly, hastily vote through ICS and IUGS in order to secure and strengthen the narratives that supports their actions. So it's a fascinating story in large organizational damage control. Thank you very much.
Thank you, Dr. Head. I think we have time for a couple of questions or comments from the audience. Once again, if you have any question or comment, raise your hand and we'll bring your microphone. Yes. Yeah.
Thank you, Martin, for this wonderful talk. You mentioned the SQS was not discussing the science in the after they got the proposal. Could you elaborate on what the discussions were about? And the other question I have is, what is the the AWG's proposal? How long is the half-time of it? So how long can you wait to resubmit without doing new analyses? Because this is a geology of the present, and when do you have to get new drill cores?
I think I got the first half of your question right, which is essentially if they weren't discussing the science, then what were they discussing? It's really a very good question, and rather the answer is rather disheartening. The discussions were over the technicalities of what could be included within the Anthropocene working group proposal, what could be looked at and what could not be looked at. For example, the Anthropocene working group proposal included both the GSSP, that is Crawford Lake, but it also included detailed reports on 3 auxiliary boundary strata types, which had also been voted on and approved by the Anthropocene working group, and they required approval by SQS. And the question was whether those auxiliary boundary strata types, which included Beppu Bay in Japan, included a Chinese and a Polish auxiliary strata type, whether they could be included. And according to ICS, they could not be included because they then made the proposal too long. Well, there's no actual requirement about how long the proposal should be. And also, the ICS's own rules allow for auxiliary strata type proposals to be submitted along with a GSSP proposal. So those rules that were laid out by ICS were actually broken in addition to the statutory regulations that were also violated. So that was, I hope that answers your first question. It was rather, as I say, rather disheartening because it was really sort of bureaucracy rather than science. Very little science was discussed. To answer your second question, there is nothing in the rules that require any waiting time or any moratorium before the Anthropocene working group can resubmit. But it's in no rush to do so. The Anthropocene working group has got a fantastic proposal. It can resubmit any time it wants, but it's been burned once already. It needs to have some assurances that the proposal would be viewed fairly, without prejudice, viewed with an open mind, viewed with a mandate to examine the evidence and to draw conclusions and to vote on the basis of the evidence presented. That's how science works, or how it should work. And until those conditions are in place, I'm not encouraging the Anthropocene working group to submit its proposal.